Okay, hello. This is Math 2. We're going to do, we're actually in Chapter 5. We're going to, or I'm going to go through 44, 47, and 48 only. And I kind of picked these ones, well, I picked 47 because it's actually fun. I thought it was fun. And then 48 is just kind of weird, and it's long. So I hope you can persevere through this problem and read the whole thing. But 44, I just want to, because 44 is kind of a catch-all. And just make sure you're actually doing your work correctly when you're solving these quadratics to get the x-intercepts. What I just want to break down A really quickly. Since you have two products that are equal to 0, you can set one of them equal to 0, and then you can set the other product equal to 0. And, you know, you would solve it, work it out, add 18 to both sides, so you get 6x equals 18. Divide by 6, you get x equals 3. That's 1. And then 3x equals negative 2, so x is equal to negative 2/3. So I don't know, see, the book is not picky, but you actually found the x-intercepts of the parabola. So I would, personally, if I were you, take one more step and actually write down the two that you found as in point system. I mean, as a coordinate. So you actually remember what it is that you actually are finding in this case. So you found the two x-intercepts of your parabola. Okay, and then this is A through F. And the one that I actually did want to go through with you, because the hints on this are pretty okay, is actually D. There's like two different ways to do this, and I actually wanted to do both ways with you, and you pick whichever way you're comfortable with. It says this is a difference of squares case, but it's not necessary for you to do difference of squares. You can do it in, like I said, I'm going to do both. So the first way is actually doing what the hint says to do. It's a difference of squares, so that means you can take the 4x squared minus 1 and you can break it apart. This is 2x minus 1 and 2x plus 1, because negative 1 times positive 1 gives you negative 1 equals 0. And I'm pretty sure you can take it from here. Okay, you can just split them up just like we did before. 2x minus 1 equals 0 and 2x plus 1 equals 0. And then solve it, x equals, and then do it in coordinate format. And that's one way to do it. You could do the difference of squares. If you didn't recognize it as a difference of squares, it's not the end of the world. It's still, you can still do this. So I would do, okay, so that's one way to do it. So you can pause here. If you like this way, that's fine. I would look at the next one. Sometimes it might be easier. So the next way is, well, if you know, well, not if you know, you should know by now how to actually solve equations, you can actually add 1 to both sides. Okay, so you have 4x squared equals positive 1. Okay. Then we want the x squared by itself, so I'm just going to divide by 4 on both sides. Get rid of the 4. Actually, not get rid. You get a 0, 1, giant 1 there, and then now you have 1/4. Okay, so from here, then you say, okay, well, x squared is equal to 1/4, so I can just, take the square root of both sides, and then I have, well, x is equal to the square root of 1 is just 1, and the square root of 4. I can break this apart for you like this. If you've never seen it that way, that's technically the same thing. Square root of 1 is just 1, because 1 times 1 is 1. Square root of 4 is just 4, because, square root of 4 is 2. Now, here's the thing, though. In the previous one, when you were doing the difference of squares, right, we broke it apart, and there were 2 answers. We know there's 2 answers, because it's an x squared, it's a quadratic, you need 2 x-intercepts. In this case, but we only solved 1, which is a common mistake. But the reality is, and some of you need to get into the habit of doing this, when you're solving for the square root of 4, technically, I could have had a negative 2 or a positive 2 as my answer, because negative 2 squared or a positive 2 squared will still give you a positive 4. So there are 2 answers here, in case you can't see them. One of them is a positive 1/2, and the other one is a negative 1/2, which is exactly what you would have gotten if you'd have done it this way. One of them was a positive, you would have gotten a positive 1/2 here, and a negative 1/2 here. Those two, which is the same thing here. We just wrote it in one area. We did a plus and a minus of the same thing. So whichever way you like, you know, I'm open to both. So it just depends on what you know for a fact. But this is a slicker way to do it. Okay, but so that's 44D. Okay, and then 47 was actually really fun. I just wanted to do it. I don't even know if you need help on it, but I just thought it was a fun problem. So let's see. Determine the measures of x, y, and z at the right. Justify conclusion using geometric relationships. Okay, so the first thing it says, remember that the base angles of an isosceles triangle are congruent. And so I look at it, I'm like, where's the isosceles triangle? And then I saw, oh, there it is. So I didn't really see the markings very well. So here's your isosceles triangle, this one right here. Okay. So that means the base angles are congruent. So if this right angle is x, this left angle on the bottom, the base angle, has no choice but to also be x. Okay, so that's x and x. Now, we have x, and 28, so we have 2x plus 28 is equal to 180. So that gives us an x value of, whatever that is, 180 minus 28, 152. Divided by 2 gives us 76. Okay, so we got 76 on this side degrees and 76 degrees on this side. And then, okay, so that's x. And then I thought, okay, well, how are we going to get to z? Oh, it's a linear pair. So x and z are on a line together, right? So that means 76 is here. So a z must be the supplement angle to 76 since they are linear. So 180 minus 76 is going to be 104. Okay, so they are a linear pair right here. Linear pair. Okay, and then to get to y, so all the way down here, let's see, x and y are actually corresponding angles. So this y and this x, as you have two technically parallel lines coming across this way. You've got like a transversal happening over here, and this angle x here and this angle y here are corresponding. And so this y is going to be 76 degrees also. Oh, that was just too much fun. Corresponding angles. Okay, that was 47. And then last one, 48. It was an essay, let me tell you. And then the answer was just weird to begin with, so I had to really think about it. So a sandwich shop delivered lunches by bicycle to nearby office buildings. Unfortunately, sometimes delivery is made later than promised. Okay, so a delay can occur either because the food preparation takes too long, so somebody's really slow in the kitchen, or because the bicycle rider gets lost, so you got a new guy. Last month, the food preparation took longer than expected, or the rider got lost 11% of the time. So it didn't, that's where I got confused. So it didn't matter if the food took longer or the rider got lost, or the food took longer and the rider got lost. It could be any combination of those. But it didn't matter, whatever it was, when they did the numbers last month, 11% of the time, something happened with the rider or the food, and 11% of the time, the food was, so one of those happened. Okay. During the same month, the food preparation took longer than expected 18 times, and the bicycle rider got lost 12 times. So, I swear I have to do color coordination. So the food preparation took longer than expected 18 times for the food preparation. And then the rider got lost 12 times. Okay, there we go. There were 200 deliveries made during the month. For the randomly selected delivery last month, what is the probability that both the food preparation took too long and the rider got lost? So what they said in this one was to use the addition rule. So the answer, 0.11%, is what happens if the union of the two. So this was the or part. We need a different color. Maybe purple. So something took longer than expected, or here's the or, the rider got lost 11% of the time. right? So I'm going to back this equation up one more because then you'll see what happens. So the probability that the food took too long or the rider got lost is equal to probability of the food too long plus the probability of the rider got lost minus the probability of the food and the rider at the same time something happened with both of them. Like the sandwich took too long and then the rider was a new guy. So F or R actually comes from the 11%, that's this part right here. So this is 11%, okay? So, or 0.11. And then the probability of the food taking too long, right, the food preparation, is actually 18 out of the 200 times was the food taking too long. And then the bicycle rider got lost because, you know, he's a new guy. Here's a bicycle rider. Okay, minus, we want to know what happened. So how much of the actual time when the food and the rider was getting done, how much of the actual time was it where it was the food took too long and the guy got lost? Okay, and that's what we're actually trying to find. So I'm going to put a giant X right here. Not because I'm crossing it out, but this is what I'm trying to find. So I'm going to do an X. Okay, so here's what we got. We got 0.11 equals, what in the world is 18 divided by 200? I don't know, some really small decimal. Okay, equals 0.09 plus 12 divided by 200. 0.06 minus x, right? Okay, well, let's combine them. 0.11 equals 0.06 plus 0.09. I'm not doing that in my head. 0.15 minus x. Okay, so far so good. I just combine those two. I'm going to subtract 0.15. Subtract 0.15, which is 0.11 minus 0.15. It's a negative. I knew that. 0.4 equals negative x. Okay. Well, I'm just going to divide by negative 1. So 0.04 is equal to x, technically, which is exactly what they got. So 4% of the time, something happened with the food and the guy got lost. Okay, so there's all that fun work. If you need to review something, please do so. And I will see you guys later.